All right. Um, so so far we've done the constant multiple rule, the sum rule, and the power rule. Now I'm gonna sort of explain why e to the derivative of e to the x is equal to e to the x. Um, Sort of. And the reason I say sort of is because I won't actually be proving part of this because I don't have the knowledge for it yet. It comes up later in my course. I'm just making these as I go. So I will come back to this eventually, but this is kind of like an understanding more so to do with um, exponential functions in general rather than just e to the x. Uh, but it is applicable. It is a pretty big part of it. So I'm gonna go ahead and just start by making a limit here. And let's say that our function is we want the derivative of a to the x as x as well as delta x is approaching as delta x approaches 0. And our our difference quotient here is going to be a to the x plus delta x minus a to the x over delta x. All right, and a property of exponents or exponentials, so forth, whatever, is that a to the x plus y is equal to a to the x times a to the y. So I'm going to apply this here with our first term of the numerator, and I'm going to rewrite this limit as this. The limit as delta x approaches 0 of a to the x times a to the delta x minus a to the x over delta x. And we can factor out a to the x here. And I can take it outside the limit because the limit itself does not affect x in any way. It only affects delta x. So I'm going to factor a to the x out of this and then multiply it by the limit as delta x approaches 0. And I'm going to rewrite the inside part here. And I'm going to have a to the delta x minus a to the x over, I'm sorry, not a to the x, over, or minus 1 over delta x. Now, a key takeaway here is I need you to understand that this right here, let me use a new color, this limit is actually a constant depending on the base a. So what I mean by this is if you think about it, this is just equal to, now the limit itself, ignore a to the x for now, okay? Ignore that for now. The limit itself is equal to f prime of x, or f prime of 0. The reason being the limit as delta x approaches 0, what we have is a to the 0 times a to the delta x minus a to the 0 over delta x. A to the 0 is 1, so we have 1 times a to the delta x minus 1, and we see that right above that. So whatever the derivative of a to the x is at 0 is effectively what this limit is equal to. So this limit itself here is a constant in a sense. It's a constant of that function or of that derivative. So just know that that is a we can say that it's equal to L, where like L is the limit, right? It is it has a value here, right? It is I don't know if constant is the right word. But I would say that there is significant understanding that it has a single value depending on the base. In terms of examples here, if a were 2, it would be 0.69 would be the value of the limit. if a were 2.5, it would be 0.92. If a were 3, it would be 1.1. So you can kind of deduce that there must exist some a where this limit is equal to 1. And that a value is e. So that's where e comes in here. I won't be proving that it's 1 because, like I said, I don't have the tools to do that yet. But just so you know, if a is e, then this limit is equal to 1. And if you were to graph e to the x on like Desmos or something, you'd see this. You'd see that when x is 0, it'd be 1. Okay, so otherwise here we have e. If we're saying that we have if a is e, then we just have our e to the x times 1, right? So that would mean e to the x, right? So in other words, d over dx of e to the x is equal to e to the x. Now, if you want to use this in an example or something, we can say find the derivative of 5e to the, let's say 5e to the x. And then, I don't know, just plus, well, we'll just do that for now. 5e to the x. So we can split this constant multiple rule here, right? We can say 5, and then we can say d over dx of e to the x, which we know is just e to the x, so it's going to just be 5e to the x. So I mean, it's pretty simple. It's pretty simplistic. It's not hard to forget. So you shouldn't have trouble remembering that. Just know there's reasons for it, right? But also, if you were to look at any exponential function, if you had like 2 to the x, you could always write the derivative as 2 to the x times this limit, whatever that value is, so that it is very useful. We did make like a major kind of undertaking there to where we have some value. We have our a to the x times this limit. I'm going to say L equals our d over dx of a to the x. So just know that that's pretty significant. Eventually, you'll have the tools to determine what L is. Not right now, but eventually. But yeah, so that's kind of the idea behind the derivative being e to the x. I will come around and prove that this limit is equal to 1 for a equals e eventually. But like I said, I don't have that right now. I should probably come out with that maybe within the week or so. So yeah, don't worry about it. I'm sure it'll be around by the time you see this or anyone sees this. But yeah.